In this video, we're going to attempt to begin solving linear equations. In this introductory look, we're going to start by noticing that if I have an equation or a relationship like 4x plus 5 equals negative 7, we will be interested in knowing what x equals. There is only one value for x that will make this equation a true equation. In this problem, it turns out that x equals negative 3. That means if I replace the x with negative 3, we should get a true equation. 4 times negative 3 plus 5. Will that equal negative 7? Order of operations tells us to multiply first, giving us negative 12 plus 5. Hopefully, that will be negative 7. Sure enough, negative 12 plus 5 is negative 7, and we get a true equation. Any other number for x will not give us a true equation in this example. So when we start with a problem, like 4x plus 5 equals negative 7, what we're going to do then to find x, to find that missing value, is we will solve by working backwards, using inverse or opposite operations. Let's take a look at a few examples where inverse or opposite operations help us find that number that x equals. As we solve these problems, we will always balance the equations on the equal sign. When I say balance, I mean if we do something to the left side of the equal sign, we must always do the exact same thing on the right side. Here, we are adding 5 to the x. The opposite of adding 5 to the x is subtracting 5. That's exactly what we will do. We will subtract 5 from one side and do the exact same thing to the other side. Notice when we do that, 5 minus 5 subtracts out to 0. We remain with x on the left and 7 minus 5 or 2 on the right. In this problem, x represents the number 2. Let's try another example. In this problem, 9 equals x minus 7. Again, we will balance through the equal sign and find x by trying to get it alone by removing the numbers with x. Here, there's a minus 7, or negative 7, with the x. The opposite of a negative 7 is a positive 7. Again, we will do the exact same thing on the other side of the equation, adding 7 to both sides. Notice the negative 7 plus 7 subtracts out to 0. We now have 9 plus 7, or 16, equals x. This is the number that x represents in this equation. Let's try another example. Here, we have 5x, which means 5 times x equals 35. Again, we will balance through the equal sign, but to undo multiplication, 5 times x, we must use the inverse or opposite operation, which is to divide. We want to divide by 5 so that we leave the x behind. Again, we will do the same thing on both sides of the equation. The 5's divide out, and we are just left with x equals 35/5, or 7. This is what x equals in the equation. Let's try one more. In this problem, we have x over 4. The fraction bar implies division. So, as we balance through the equal sign, we will do the inverse or opposite operation of division, which is to multiply. To get rid of divide by 4, we multiply by 4 on both sides. Notice again the 4's divide out, and we're just left with x equals 3 times 4, or 12. By working backwards and using inverse or opposite operations, we can find what x